Hello everyone, in this lesson we will talk about inverse functions. First of all, let's just do this little activity where we consider the function y equals radical x minus 1. We will sketch this function and then sketch its inverse by interchanging the x and y coordinates. We will use x coordinates x equals 1, x equals 2, x equals 5, x equals 10, and so on to help to sketch the curve. So we have x equals 1, x equals 2, x equals 5, x equals 10 in the table, and then y is equal to radical x minus 1 to find the y values. So radical 1 minus 1 at x equals 1, the y equals 0, x equals 2, y equals 1, x equals 3, y is equal x equals 5, I mean y equals 2, x equals 10, and y equals 3. So the coordinates points that we will be plotting for the y equals radical x minus 1 will be 1, 0, 2, 1, 5, 2, and 10, 3. And draw a smooth line through that, and this is your graph. The green curve is your graph of y is equal to radical x minus 1. Now we want to plot its inverse by doing a simple activity, just interchanging the x and the y. It's like interchanging domain and range values. 0, 1, 1, 2, 2, 5, and 3, 10. Again, for this inverse, we draw a smooth curve through it. Draw the smooth curve through the through points right here and make it red. And so this is your inverse. That's your inverse, right? So that's y is equal to radical x minus 1 and its inverse. We asked, can we find a line of symmetry? Now, a line of symmetry is a line that divides the space between the two curves equal parts, so that one is a mirror image of the other. So if we could find the halfway line between both curves, be a line looking like this, going through the origin all the way evenly. And this is a special line. That's a line y equals x. That's a line y equals x. Okay, so y equals x is your line of symmetry. Let's talk about one-to-one functions. Talk about one-to-one functions. Now, by definition, a one-to-one function, a function with domain D and range R is a one-to-one function if either of the following equivalent conditions are satisfied. 1, whenever A is not equal to B in the domain, then f of A is not equal to f of B in the range. And 2, whenever f of A equals f of B in the range, then A is equal to B in the domain. One-to-one functions pass both the horizontal line test and the vertical line test. So it passes both the vertical line test and the horizontal line test. One-to-one functions have an inverse function. A one-to-one function has an inverse function. Let's look at a couple of examples real quickly. Determine if the function is one-to-one. F of x is equal to radical 3x. F of x is equal to radical 3x. Using one of the positions from our definition for one-to-one function, one that says f of a equals f of b. If f of a equals f of b, then a equals to b. Then what we want to do is that we want to put a and b into our original function, which is f of x is equal to radical 3x. So we have radical 3a equals radical 3b. Then to undo the radical, we square both sides. We get 3a equals 3b. Then divide both sides by 3. We end up with a equals b. So f of x is a radical function, is a one-to-one function. If this situation occurs, the situation where we have f of a equals f of b, and we can algebraically show that by doing that, a is equal to b only. Okay, we can also show that a function is one-to-one if we can graph that function and it passes both the horizontal line test and also the vertical line test. So if it passes both the horizontal line test and the vertical line test, then it is 1 to 1. Okay? And let's talk about finding inverses. So, algebraically finding inverses, it is a multi-step process wherein first step you replace f of x with y. If you're given an equation or a function with f of x, replace it with y, then interchange the x and y in the equation. Thirdly, we solve for y in the new equation, then replace y with f inverse x, and then finally we can do the check to say if f inverse composed with f, right, or the f inverse of the f of x equals x, and also the f of f inverse of x equals x, right? The two functions f of x and g of x are inverses of each other if f o g of x equals x and g o f of x is equal to x, right? Okay, so let's look at a couple of examples. Determine if f and g are inverses of each other. Determine if f and g are inverses of each other. So what you have to do in this case is to do f o g of x and g o f of x, right? And if both of them equal to x, then they are inverses of each other. And notice they must also be invertible, 1 to 1, and the domains must exist. So let's do f o g of x. F o g of x would be the f of the g of x, which should be the f of radical 2 minus x, which should be equal to negative of radical 2 minus x squared plus 2, and so that was going to be equal to negative 2 minus x plus 2, and that's equal to x. And also let's check that the GOF of x is equal to x. So GOF of x is equal to g of the f of x, the g of the f of x, right? Let's fix that g up there. So that's going to be equal to the g of negative x squared plus 2. And so that would be equal to radical, right? Radical of 2 minus parentheses negative x squared plus 2. And so that's going to be equal to, if you expand this out, it's just going to be radical 2 plus x squared minus 2. And so that's going to be radical x squared, and then that is equal to x. So notice that both the f of the g of x equals x, and the g of f of x is equal to x. So f and g are inverses of each other, are inverses. F and g are inverses of each other, okay? All right. Now, let's look at how we can find inverses. Let's use the steps to find inverses. Alrighty, so let's find the inverse of f of x is equal to 5 minus 3x, so number 6 right here. F of x is equal to 5 minus 3x. And notice we said we were going to use some steps. So step 1, we would replace f of x with y, so we have y is equal to 5 minus 3x. Right, then interchange the y and x. So step 2, interchange the y and x. So we have x is equal to 5 minus 3y. And then the rest is algebraically solving for y. So what we have now is that x minus 5 is equal to negative 3y, and then divide both sides by negative 3, and then y will be equal to x minus 5 over negative 3. And finally, you replace your y with f inverse of x, so f negative 1x is equal to x minus 5 over negative 3. X minus 5 over negative 3. Also, if you had done it the other way, where you had just put the y on this side and bring the x across, then alternatively f inverse of x would be the same as 5 minus x over 3. So f inverse of x, let's write this notation correctly, f inverse of x be equal to 5 minus x over 3, if you've done the algebra a little bit differently. All right, now let's talk about another problem, number 7. 7x plus 4 over 4x minus 9. So the inverse of 7x plus 4 over 4x minus 9. And so that is your f of x equals that. So we write step 1, y is equal to 7x plus 4 over 4x minus 9. And then your next step is to replace y with x. So x equals 7y plus 4 over 4y minus 9. So that's the next, right? For our next step. So this is step 2. Now let's continue with this work and let's see what happens with it. Doing a bunch of algebra right here. We multiply both sides by 4y minus 9, so x by 4y minus 9 is equal to 7y plus 4. Then distribute 4xy minus 9x is equal to 7y plus 4. Then we want to bring the y's to one side. Subtract 7y from both sides, so 4xy minus 7y. And we can add 9x to both sides. Be 9x plus 4. Then we can factor out the y from the right side. So y, 4x minus 7 is equal to 9x plus 4. And so finally, divide both sides by 4x minus 7, y will be equal to 9x plus 4 over 4x minus 7. And then we replace y with f inverse of x in our final step. And so f inverse of x will be 9x plus 4 over 4x minus 7. And we are done. We can also check to show that that was really the inverse by doing f inverse of x, f of the f inverse of x, and f inverse of the f of x. Okay, quickly let's talk about domain. To find the domain and range of an inverse function, you may find the domain and range of the original function and then switch these. So the domain and range of the domain of the original function is the range of the inverse and vice versa.